Hello everyone, welcome to this video. In this video we're going to get started with the transport layer. Alright, so in the previous video we looked at the network layer, and now it's time to get started with one of the most important layers on the OSI model, and one of them that Nmap utilizes really strongly, and that is the transport layer. Alright, so let us look at what the transport layer is. Well, the transport layer is essentially used for the transfer of packets between two hosts for the application layer. Alright, so it is used for the transfer of packets between two hosts for the purpose of the application layer. Now we'll look more into this as we move along. Alright, now let's get started with the protocols that are used in the transport layer. Now getting started, we have the ICMP protocol, alright, which is the Internet Control Message Protocol. We'll look at what it does in a few seconds. We then have your UDP protocol, which is your User Datagram Protocol. And finally, one that you may be familiar with, or you should be familiar with, that is the TCP, or your Transmission Control Protocol. Alright, so let's look at how each of these works. Alright, so if we go into the ICMP, which is the Internet Control Message Protocol, you can see that it is an error reporting protocol that is used by routers, hosts, and network devices to generate error messages when there are problems delivering IP packets or Internet Protocol packets. Alright, so the primary function for the ICMP or the Internet Control Message Protocol is it is used to send messages, and it is used to perform network diagnostics. We'll be looking at this a lot with Nmap, and I'm sure you'll be really excited to see how this works. Alright, so the most important thing to understand is that it is used to send messages or probes, and it is used to perform network diagnostics. The one thing you need to understand is that ICMP is not a transport protocol that sends data between systems, so it does not deal with the sending of data. Now, when it comes down to the ICMP header, we have two types of flags or messages that are in the ICMP header. Alright, so you have the request and the response pair. Alright, so now this, I'm pretty sure you have heard of it, but it simply revolves around the echo request and the echo response. So we'll be looking at all of these ICMP requests and response pairs. Again, these are quite advanced, but when performing the scans, I'll be explaining them. The only thing you need to understand is that you have your echo request, you have your timestamp request, etc. And since they're in pairs, you have your echo request and your echo response. Alright, moving along to the UDP, which is the User Datagram Protocol. The UDP is used primarily for establishing low latency connections between applications on the internet. Alright, now the two common features about UDP is that number one, it is very unreliable in the sense that the packets are not, there is no guarantee that the packets will be delivered to their destination. And the great thing about it is connectionless in the sense that there is no handshake process required. We'll be looking at the three-way handshake when we'll be talking about the TCP or the Transmission Control Protocol, but for now just understand that UDP is used for, it's essentially used for establishing low latency connections between applications on the internet. Now the great thing about it, as I said, it is firstly connectionless in the sense that there is no handshake process, and secondly, it is extremely fast. Alright, now when it comes down to its disadvantage, it is very unreliable in the sense that you have no guarantee whether or not the packets will be delivered to their destination. Now looking at the UDP header, we have our source port and our destination port. Alright, so the UDP protocol essentially, as I said, is used for low latency connections. So the source port that it will be leaving in terms of the ports that it will be used for communication will essentially, it will use a range of ports that is not very commonly used. So you can talk about ports like port 4000, etc. And finally, the destination port is going to be selected from a static and well-known list of ports. For example, it will target the port 80 where you have your your different protocols that are running. You have your web server that's running on port 8080. Sorry, that is not supposed to be on port 80, but on port 8080. Alright, so that is the UDP or the User Datagram Protocol. When it comes down to the TCP or the Transmission Control Protocol, TCP is essentially a standard that defines how to establish and maintain a network conversation via which application programs can exchange data. Alright, so it's a protocol that governs how two devices or two or more devices can establish a connection between themselves, and obviously how they can exchange data between each other. Alright, now the great thing about TCP is that it's very, very reliable and it is ordered. Okay, now looking at the TCP header, this is very, very important to understand in terms of the information stored in the TCP header. You have your source port and your destination port. Again, all from a list of, firstly, your source port leaving a port that is not very, very commonly used, and the destination port, going to ports that are very, very common, like port 8080. Your port 80 itself, and for example SSH connections going through port 22. And finally, the last piece of information that is very important that is carried in the TCP header are the flags. Now we'll be looking at what flags we're talking about here, and more specifically we'll be looking at this in the next video when we'll be talking about the three-way handshake and why it is important to understand how it works. Alright, so I'll be seeing you in the next video, and we'll get started on the three-way handshake and how a connection is established. Alright, so I'll be seeing you in the next video.